Hello and good afternoon my dear kids. Welcome back once again to this short tutorial video for class 8 students under the maths topic. And since we have dealt with few sums regarding the dealing with the angles of the triangles, and we are doing the same topic, so in this one we'll be dealing with the right angle triangle. Okay, a totally new topic. As I've already said, the right angle triangle is a very important triangle, isn't it? And now, before moving on to the topic, what I want you to tell you is that today in this video we'll be dealing with these sums regarding Pythagoras theorem. Okay, we'll be just the entire video will be just for Pythagoras theorem, one theorem. Okay, so actually what Pythagoras is he was a mathematician. Okay, he was a mathematician, and what he told was what he derived actually, and that is why when he derived a theorem, that is why a formula actually, and that is why that formula or that statement was known as Pythagoras theorem. Okay, what he told was, he told that in a right angle triangle. Okay, so that is why I said the right angle triangle is very important, and remember the Pythagoras theorem is only applicable on a right angle triangle. Okay, now what he said was, in a right angle triangle, if two sides of the triangle are given, see, Pythagoras theorem, it deals with the sides of the triangle, not angle. Remember that. Okay, it deals with the sides of the triangle, not angle, and it only deals with the right angle triangle. Okay. What he said was, if two sides of a right angle triangle are given, then I could derive the third side. That's what he said. Okay, and he proved it, and he has given us the formula as well. Okay. He said that when two sides of a right angle triangle are given, he can calculate the third side. So, as I've already given you this one, isn't it? Because the terms are very important. Say in a right angle triangle, I have already told you, this side is known as base or adjacent. This one is known as perpendicular or height or altitude. The line which is drawing 90 degree angle. The bottom one is known as base, and the longest side of the triangle. And remember, this side will always be equal opposite to the 90 degree. The longest side, it will be the longest side as well, and it will always be opposite to 90 degree. That side will be known as your hypotenuse. Okay, so how he derived the formula, how he has given the formula was, Pythagoras, he gave us a formula that states base square plus perpendicular square equals to hypotenuse square. Okay, simple. Base square plus perpendicular square equals to hypotenuse square. So he derived this formula, and simply because of this formula, this formula is known as, it was given after his name, and simply this formula was given after his name, and that is known as Pythagoras theorem. Okay, the statement is simple, that is base square plus perpendicular square equals to hypotenuse square. Okay, so let's go with few sums. Okay, it will be easier for you to understand with few applications of this theorem. Okay, now from exercise 17b, what do we have here in exercise 17b is the figure is given as this. See, though it's a right angle triangle, we know that it's a right angle triangle, isn't it? Because see the symbol, it's a triangle, right angle triangle, but see it's like being tilted, isn't it, or rotated, isn't it? The triangle is being tilted or rotated, isn't it? So if you cannot figure out now the sides of this triangle, that means which side is which. I'm actually referring to the names of the sides. Okay, if you can't figure out the names of the sides, because see what we had dealt with was, we had dealt with this triangle, this the position. We had dealt with this position, isn't it? And the position is slightly been rotated, isn't it? If you can't figure out, then what you can do is you can simply rotate the triangle. See what I have done here is I have simply rotated the triangle. See, now see, while rotating the triangle, what you are supposed to keep in mind is, see where your 90 degree was. First of all, see simply first of all, we are familiar with this figure or the position, this position. So that is what I have drawn here. The same triangle, the same position. 90 degree was here. Okay, 90 degree was here. Okay, 90 degree was here. Now I can easily figure out the sides because I have given you this, isn't it? We know that this side is hypotenuse. Now I know this side is hypotenuse, this side is perpendicular altitude or base, perpendicular altitude or height. This side is base, isn't it? Now since we have rotated this figure to this position to this position, now how to see? But what happens is you need to see, but actually what was given in the question, that is very important, isn't it? The sides, proper sides. So in order to write the sides properly, how you need to figure out is, see, what did I said? The side opposite to 90 degrees hypotenuse. That's what I said, isn't it? This is 90 degree. Which is the opposite side to that? This one. And this one was the longest side, also hypotenuse, and it was referred as x in here, denoted as, isn't it? So see, here too, the side opposite to 90 degrees is hypotenuse, and I have referred it as x. Now see, yes, now what you can figure out is, or you can simply rotate the figure as well. See, if you rotate the figure position, this is your base, this is your altitude, this is your hypotenuse, isn't it? The same figure, simply I have, see, tilted the position, rotated the figure, and have written the values of the sides. So see, the base is 9, altitude is 40. Now what we need to calculate? We need to calculate the value of x. So where is our x? It's in hypotenuse, isn't it? Now what we know, see, the way of writing, you have to write, see, every time you deal with the right angle triangle and you deal with the sides of the right angle triangle, every time, see, Pythagoras theorem will be applicable, and you have to write this way. So according to Pythagoras theorem, we know hypotenuse square, the formula is equals to base square plus perpendicular square. Same thing, isn't it? Base square plus perpendicular square equals hypotenuse square, or hypotenuse square equals to base square plus perpendicular square. It's the same thing, isn't it? So hypotenuse square, hypotenuse was given in terms of x, so x, see, x square equals to base was given as 9, so 9 square plus perpendicular is 40, 40 square. Now x square equals to 9 square means 81, 9 into 9, 40 square, 4 square is 16, 0 square, so we need to add 2 more zeros, so 2 zeros. Now 16 plus 81 is 1681. Now this step we are doing it for the first time. See, whenever you remove square from one of the sides, actually it's a linear equation one variable, isn't it? This statement up to here it's linear equation one variable, but you haven't never come across with the power of the variable, isn't it? Whenever you have a square on one of the sides, whenever you have a square on one of the sides, while removing the square on the second line, what I did, see, I have removed the square from left side. When you remove the square from one of the sides, you need to place square root on the other side. Okay, listen carefully once again. I'm going to repeat it. Whenever you remove square from one of the sides, you need to replace it with square root on another side. So square root 1681. Now you have known the concept of square root, we have already done, isn't it? So square root of 1681 is 41. So we got the value of x as 41. Okay. Okay, for the next one, question number 3, yeah. That figure was, it was already given in our that familiar position, isn't it? See, simple, same position. The base is missing, we got a hypotenuse 8.5 and we got altitude as 8.4. So what we know, simple, we know that according to Pythagoras theorem, hypotenuse square equals to base square plus perpendicular square. So I have substituted all the values, say hypotenuse 8.5 square, plus base I have got m, so m square, plus perpendicular square, I have got perpendicular as 8.4, so 8 square. Now, variable on one of the sides, the constant terms, see, I have taken 8.4 to the other side, so it becomes minus, see, m square equals 8.5 square minus 8.4 square. Now see, now from this portion it can be done in solved in two different ways. Okay, first type, like type 1 and type 2, I have solved one of the types in here, solved another type in the second page. Okay, I'll show you. Okay, and this one, the general one, 8.5 square, so 8.5 square is 72.25. You need to multiply 8.5 and 8.5, isn't it? So it comes 72.25, 8.4 into 8.4, 70.56. Subtract it, you will get 1.69. Now m square equals to 1.69. Remember, you cannot just remove the square. M square equals to 1.69. Now as soon as you remove the square, m equals to, so it will be square root of 1.69, isn't it? So square root of 1.69, and square root of 1.69 is 1.3. See, the square root part we have already done before as well. Okay, okay, those who couldn't recall, wait. Okay, in the end I'll explain regarding this as well. Okay, one more time. So okay, till here Square root of 1.69 is 1.3. Okay, so okay, now as I already told you, that can be done in another type as well. So see, another type, what I have done here is I have written m square equals 8.5 square minus 8.4 square. Now see, what I have done is I have used identity. See, it's actually in the form a square minus b square, isn't it? And what do I know? A square minus b square. It is a plus b into a minus b. So that is what I have done here. See, a square minus b square, a plus b, a minus b. So when you add these two, you'll get 16.9, and when you subtract these two, you'll get 0.01. So now when you multiply 16.9 with 0.1, actually you are multiplying it 1, isn't it? The value remains same, but since because of the decimal will switch its place, so it became 1.69. See? Now it was m square, so we needed m, isn't it? So m equals to square root of 1.69, that is 1.3. Okay? Now yeah, for those who didn't understood how I got the value 1.3 is simple, square root of 1.69. Now I have removed the decimal on the second step. See what happens when you remove the decimal. The decimal has jumped 2 digits, so 2 zeros in the denominator, that it makes it 100. Take on the prime factors. See, 169 means 13 into 13, 100 factors, 2 into 2 into 5 into 5. From square root, what happens? From 2 factors, one of the factor comes out, isn't it? So from 2 13, one of the 13 came out. From this 2 to 1 2, this 2 5, one of the 5. So actually it is 13 divided by 10. 2 5 times is 10. Now if you want to remove the 10 from the denominator, what happens? You need to place 1 in the a decimal before 1 digit. So that's what I have done here, 1.3. So that is how you get the result as 1.3. That is how we got the value of m. Okay, I hope you guys understood this one. Okay, it's easy, isn't it? But all you need to remember is that, see, we are dealing with the sides of the triangle in here, that too particularly a right angle triangle, and that too only then, see, on the Pythagoras theorem, as I have already said in the beginning as well, the Pythagoras theorem is applicable only when it deals with a right angle triangle, and that too with the sides of a right angle triangle. Okay, for question number 2, the figure is given as this. See, again, a right angle triangle, we know. How we know it's a right angle triangle? Because of this symbol, isn't it? The sides are given as 4.5 and 7.5. We don't know which are the sides, isn't it? But what we know is the side opposite to 90 degree is hypotenuse, and that's empty. And what we need to find is, we need to find hypotenuse. That's what we get. So what I've done here is I've simply drawn the figure as per my convenience. So this is not mandatory. Okay, why I'm doing in all the sums, this is because I needed to show you. Okay, so that it will be easier for you. Okay, so I've just tilted again mirror image of this triangle. So 4.5, see, the altitude remained the same, the base 7.5, and the hypotenuse was missing, so is here, the hypotenuse is missing. So what we need to find? We need to find the hypotenuse of the triangle. That's what we get to know, isn't it? So now, according to Pythagoras theorem, what we know? According to Pythagoras theorem, the formula is hypotenuse square equals to base square plus perpendicular square. Now base here we have is 7.5, so 7.5 square I have substituted. Perpendicular I have as 4.5, so substituted as 4.5. Now in this one, 7.5 square plus 4.5 square. Now we don't have any identity. Okay, for those who wants to go with the second type, like for this one, we cannot go in this one. We cannot use any identity because we don't have any identity for a square plus b square, isn't it? So all you need to do is just go with the regular method. That is, first take the square, add them up. Okay, so that is what I have done here. See, I have taken the square of 7.5 and 4.5, that is 56.25 and 20.25. I have added them up, 76.5. It is actually hypotenuse square, but I needed hypotenuse, not its square. So what happens when you remove the square? I've already taught you, isn't it? Square root to the other side. So square root of 76.5. So take out the square root of 76.5. You'll get your value as 8.7. Okay. Either you can go with the this two. You can go with the taking it and the fractional form, or like as I have done here, go with the fractional form, or what you can do. I have taught you this as well by long division method. How you do the square root of decimal numbers. I taught you that, isn't it? So that too. Okay, will give you result as 8.7 meter. Okay. So the last sum for today that we have taken is this one. Oh, I forgot to use the symbol. Remember to use the symbol. Okay, because if you haven't used the symbol, that means it's not necessary that it has to be right angle triangle, because sometimes what happens is the angle slightly be tilted, like the angle is 89 degree, could be, isn't it, or 91 degree, isn't it? So the symbol is very important. Okay, so also in question number 3, it's directly given the hypotenuse is missing, we know, and the base is given and the perpendicular is given. What we need to calculate is calculate the hypotenuse. So again the same thing happens according to Pythagoras theorem. Hypotenuse square equals to base square plus perpendicular square. Hypotenuse is we need to find out. So what I want you to do is I want you to complete this sum. Okay, the hypotenuse is missing. Please substitute the values, okay, given terms or the terms in the equation, then figure out the value for the hypotenuse. Okay, that will be your homework. Okay then, so I hope you guys have understood today's lesson. Okay, so stay tuned in for more videos and updates. Till then, stay safe. Bye bye.